Hi everyone, welcome to my channel. This is Mrs. Anderson, and in this video I'm going to talk about special right triangles. The first one I want to go over is the 30, 60, 90 degree triangle. For all right triangles, the hypotenuse is always going to be the longest side. And so for a 30, 60, 90 triangle, that side can be represented by the portion 2x. The side across from the 30 degrees is always considered the shorter side, or the shorter leg, from the remaining two sides that are not the hypotenuse. That side is going to be used, or labeled as x. The side across from 60 degrees is always the longer side from the remaining two sides, and that one will always be labeled x radical 3. The reason that this happens is because 30, 60, 90 right triangles have a special relationship with each other with what numbers you have in the angles and what the numbers across the sides have. They always have this common factor between them that allows us to always set up these triangles this way. So I want to show you exactly how you can use this on a 30, 60, 90 triangle. So for this first one here, you can see where the 30 degrees are and where the 60 degrees is and where the 90 degrees is. Now across from the 90 degrees is the y. Across from 30 degrees is 7, and across from 60 degrees is x. We want to solve for x and y. So for this triangle, y is on the hypotenuse side, so that's going to be represented by 2x. 7 is the shorter side because it's across from 30 degrees, and so that one would just be the x. The x on my picture is the longer side because it's across from 60 degrees, and so that's represented by x radical 3. I will say that for 30, 60, 90 triangles especially, you need to be very careful with your variables because they can become confusing very quickly, especially when you're using x multiple times. The easiest thing, and something that you could also do if you wanted to, is to rename those x portions on the special right triangle with a different letter, like n or L, so that it's not something that will be x and y, because x and y is used a lot in math. But if you can keep straight of when I say x on the triangle is different than the x on the special right triangle, then you can always just keep those letters the same. The solution for this one then is that x is going to be 7 times the square root of 3 and y is going to be 14. So let's talk about how I got that. Because 7 is across from 30 degrees, and that's known as the x portion, x is equal to 7. Now, on the longer side where it says x, that was the x radical 3. So because 7 is x, that goes in for that one, and that's why I have 7 times the square root of 3. The y side is represented by 2 times x, so 2 times that 7, which is going to be 14. For this one, across from the 30 degrees is my x, across from the 60 degrees is 4 radical 3, and across from the 90 degrees is y. So again, let's solve for x and y. For this triangle, y is that hypotenuse, so that's going to be the 2x portion. X is the shorter side, so that's going to be equal to x. This one should be a little less confusing with the variables because the x side is actually equal to x from my special right triangle. The 4 radical 3 is the longer side because it's across from the 60 degrees, and so that's equal to the x radical 3 side. In order to solve this one, we use that 4 radical 3 side is equal to that x radical 3 side. Notice how they both have the square root of 3 attached to them. If I were to divide one side by radical 3, I would have to divide the other side also by radical 3. Well, anything divided by itself in math is always equal to 1, so essentially they cancel each other off and you're left with 4 equals x, or x being equal to 4. So my x portion up there on my triangle is just going to be 4. Now y was 2x, so we're going to take 2 times 4, which would be 8. So x is 4 and y is 8. Let's look at a challenge problem. So for this one, I have across from the 30 degrees is my x, across from 60 degrees is 8, and across from the 90-degree angle is my y. Again, I want to solve for x and y here. For this triangle, y is still the hypotenuse, and so that's going to be the 2x portion. X is going to be the shorter side, so again, equal to x. 8 is the longer side, so that's going to be equal to that 8 radical 3. For this one, we need to use that 8 being equal to the x radical 3. Now this one is not as simple as the one before because 8 does not have a radical 3 attached to it, so they do not just cancel right off. We're going to have to do a little bit more work here to get rid of that radical 3. So to set it up, we divide both sides by the square root of 3, like we would have done on the last problem. For this one though, when you divide by the square root of 3, it's left in the denominator on the left side. You see 8 over the square root of 3. Now we cannot leave square roots in the bottom of our fractions, so we need to do what's called rationalizing the denominator. So in order to do that, you have to multiply by that square root of 3 on the top of the fraction and on the bottom of the fraction. On the top, you're just going to stick 8 next to the square root of 3. Because they're not both underneath the square root sign, or they're not both out of the square root sign, we cannot combine them any further than that. On the bottom though, because 3 and 3 are both underneath square root signs, you can multiply those. And that's why I have the square root of 9, because 3 times 3 is 9. Now the square root of 3 is going, or the square root of 9 is going to be 3. So that pops out, and so I'm left with 8 radical 3 over 3 being equal to my x. In order to solve for y, we need to take 2 times my x portion. So you only take 2 times the 8 on the top, nothing else. And you get 16 square root of 3 over 3. On to the next special right triangle, the 45, 45, 90 triangle. I personally feel that the 45, 45, 90 triangle is a little bit easier than the 30, 60, 90 triangle. The reason for that is because you have two angles that are both 45 degrees, so both sides across from that are going to be equal as well. So you can see on my picture here, across from the 45-degree angles, you have x and x. Now across from the right angle, the hypotenuse side is going to be x square root of 2 for this triangle. This is basically an isosceles right triangle because you have two congruent sides. The hypotenuse again is always the longest side on the right triangle, and so that side is going to be represented by x radical 2. And the sides across from the 45-degree angles will always be the same measure, and so those are just called x. Let's do a practice problem. So across from my 45, 45, I have one side being x and one side being 10, and the right angle across from that is the y. So y is that hypotenuse, which is going to be represented by that side x radical 2. X and 10 are going to be equal because they're both across from the 45-degree angles. So we should already know that x is going to be equal to 10, so really we just need to solve for y. Because x is 10 and y is going to be x times the square root of 2, we just plug 10 in for that x, and so y is going to be 10 radical 2. For this next one, same setup except across from the 45-degree angles, from one of them is 4 radical 2. Y is still the hypotenuse, so that's still going to be the x radical 2 side. X and 4 radical 2 are going to be equal again because they're both across from 45 degrees. So x is going to be equal to 4 square root of 2. Now to solve for y, again like I did on the last problem, I need to plug in that 4 radical 2, that whole portion, in for the x up above where it says x radical 2. So what that's going to look like is you're taking 4 square root of 2 times square root of 2. 4 square root of 2 being the x portion, and then the square root of 2 comes up from x radical 2. Underneath the square roots again we can multiply 2 times 2, so we have 4 times the square root of 4. The square root of 4 would be 2, so because that 4 is sitting out front, you take 4 times the new 2 and you get 8. For this one, again solving for x and y, 12 is your hypotenuse, so that's going to be the x radical 2 side. X and y are going to be equal because they're both across from the 45-degree angle. In order to solve this one, we have to use the hypotenuse, that 12 being equal to 8 radical 2, and we need to solve for the x. This is very similar to that problem we did before with the 30, 60, 90 triangle, where we're going to have to rationalize this denominator. Because when I divide both sides by the square root of 2, I'm left with 12 over the square root of 2, which we can't leave that square root of 2 in the denominator. So we multiply the top and the bottom by the square root of 2. So that leaves us with 12 radical 2 on top, and on the bottom, the square root of 4. Now the square root of 4 is going to be 2, so I have 12 radical 2 over 2. I can simplify that 12 and that 2 on the bottom because they're both whole numbers, so I get 6 square root of 2 from my x. Now because my 45 degree angles have x and y across from them, that means that x and y are going to be the same. So because x is 6 square root of 2, y should also be 6 square root of 2. If you're ready to give it a try, I've created a practice quiz on a website called Quizizz.com, and it is a multiple choice platform where you can go and practice the skill you just learned. The link to that can be found below in the description, but I've also included it here for you to type into your URL if needed. I hope you learned something from this video, and thank you for watching.